What is the lower limit in engineering tolerances? Imagine you're building a tiny machine where every part has to fit just right. If a piece is too small or too big, it might not work properly. That's where the idea of the lower limit comes in. It's the smallest size a part can be made without causing problems. Think of it as the minimum acceptable measurement for a part to still do its job. If a part measures below this limit, it's considered out of tolerance and can't be used. In engineering, tolerances are the allowed variations from a specified size. These variations are bounded by two limits, the upper limit and the lower limit. The upper limit is the largest size a part can be, while the lower limit is the smallest size. The difference between these two limits is called the total tolerance. For example, if a shaft is supposed to be 40 millimeters in diameter, with a tolerance of plus or minus 0.2 millimeters, the lower limit is 39.98 millimeters. That means the shaft cannot be smaller than 39.98 millimeters, or it won't fit properly in the assembly. The lower limit is important because it helps ensure parts fit together correctly. If a part is too small, it might cause loose fits or excessive clearance, which can lead to mechanical failure. For example, in a shaft and hole setup, if the shaft's diameter is below the lower limit, it might be too loose, causing vibrations or wear. On the other hand, if the hole is too small, the parts won't fit at all. There are different types of tolerances where the lower limit plays a role. In bilateral tolerances, the size can vary on both sides of the nominal or target size. For example, a dimension might be 1.5 millimeters plus 0.0 and minus 0.5 millimeters, making the lower limit 1.495 millimeters. In unilateral tolerances, the variation occurs only in one direction, either above or below the nominal size. Designers and manufacturers determine the lower limit based on what the part needs to do, what manufacturing processes can achieve, and industry standards. For example, standards from organizations like the American National Standards Institute or the American Society of Mechanical Engineers provide guidelines for setting these limits. Properly specifying the lower limit helps keep parts interchangeable, reliable, and functioning as intended. It's a simple but vital part of making sure everything fits and works smoothly in mechanical systems.